Welcome back to everybody. I am Professor K.K. Matthew from Bangalore, India again. Look, now we are coming out with our fourth part of the course, namely Python Programming Inside Out, Part 4. Already I have published Part 1, Part 2 and Part 3. This one is Part 4, Python Programming Inside Out, Part 4. In a few days' time, I will be coming out with Part 5. Here we are discussing Python variables, constants and literals. And the example program pertaining to each concept also is discussed. Rules and naming conventions for variables and constants are also discussed. Literals, especially numeric literals, are discussed in the end. So it's a video session where we'll be getting a general idea again about the basics of Python programming, like Python variables, constants, and literals, etc. So go through this video session. If you have missed the previous videos, you please go through from part 1, part 2, part 3. This is part 4. So whatever you feel about my lectures on this subject, you can just forward your comments and feedbacks. Absolutely, I'll be welcoming it like anything. So happy programming. We will come to an end now. Python variables, constants and literals. Variables. In most of the programming languages, a variable is a named location used to store data in the memory. Each variable must have a unique name called identifier. It is helpful to think of variables as containers that hold data which can be changed later throughout programming. Which can be changed later throughout programming. Declaring variables in Python. In Python, variables do not need declaration to reserve memory. To reserve memory space, the variable declaration or variable initialization happens automatically when we assign a value to a variable. Assigning value to a variable in Python. We can use the assignment operator =, to assign the value to a variable. For example, look, website is equal to apple.com. Apple.com is in double quote. In the above assignment, we assigned a value apple.com to the variable website. Keep in mind that Python is a type inferred language. That means it can automatically infer. That means it can automatically know that apple.com is a string and declare website as a string. And declares website as a string. Assigning values to a variable in Python and changing value of a variable. Look, it's a very simple program wherein we are considering variable declarations. Look, here website is equal to apple.com. Apple.com we have put within double quote. Means apple.com is a string. Look, observe Python is a type inferred language. And hence, by assigning the string apple.com to the variable website, it automatically becomes a string data type. So, website is now a string data type. Look, it's so very simple. That is the great convenience of Python language. You don't have to explicitly declare a variable's data type. You simply assign whichever value you want to a variable. Automatically, the variable becomes the corresponding data type. Okay, next. Print website. It's now printing the website apple.com. It will print. Now, again, assigning a new variable to website. We are now rewriting. We are assigning another variable to that particular, another string to that particular variable. Look, again, website is equal to programmingpython.com. Programmingpython.com is a string that has now been assigned to website. Again, print website. We are again printing the new website. Print website. So now let us see how we can run it. Either you can go here, run, and make this run. Better you always use this run. Then it will come whether it is the pych05. Our file name is pych05.py. Just click pych05. Yeah. See, we have the result as apple.com. Next, programmingpython.com. So the result has come. Apple.com and programmingpython.com. Okay, fine. It's a very simple program. We will come to an end. Yeah, we are continuing with variable declarations. This time you look at it. Assigning multiple values to multiple variables. Multiple values are being assigned to multiple variables. Look, this is the comment I have given. Comment hash means it is for comment. Assigning multiple values to multiple variables. Look, A, comma, B, comma, C is equal to 5, comma, 3.2, comma, hello within double quote. Hello is a string. See, I have put a comment. Very, very flexible a system. Very, very flexible in fact. See, A is equal to, A is, we have not, we have mentioned simply A, comma, B, comma, C. And then we have put 5, comma, 3.2, comma, hello. It means 5 is assigned to A, 3.2 is assigned to B, and the string hello is assigned to C. Fine. Look, very, very flexible a system. Print A, next print B, next print C. It will print the values of A, B, and C respectively. Line after line. Okay, fine. Next, again a comment. If you want to assign the same value to multiple variable at once, we can do this as. Look, x is equal to y is equal to z is equal to same. Same is a string. Same we have put within double quote means same is a string. Then print x, next print y, next print z. Let us see how the result comes. Look, these are all fine. Now we'll just try to run it. Run pych06. Yeah, just a click. See, you are getting the result. See 5. See print A. It is actually so it's 5. Print B. Again it is 3.2. Print C. Hello. Then here x, y, and z are the same. It is actually the string same. So print x, print y, print z as given. See, same. Everywhere the same string. It's so very beautiful. See, it's one of the greatest languages, modern languages. If you compare these facilities available in Python with any of our traditional languages, you won't find this type of features. It's great to learn Python. Okay, we will come to an end. Constants. A constant is a type of variable whose value cannot be changed. It is helpful to think of constants as containers that hold information which cannot be changed later. Assigning value to a constant in Python. In Python, constants are usually declared and assigned on a module. Here the module means a new file containing variables, comma, functions, etc., which is imported to the main file. Inside the module, constants are written in all capital letters and underscores separating the words. Declaring and assigning values to a constant. An example follows. Create a constant.py file first as follows. Create a constant.py file first as follows. Pi, both are capital letters. Pi is equal to 3.14. Next, gravity is equal to 9.8. Then create another file, say main.py as under. Then you do import constant, print in bracket constant.py, output will be 3.14. Again print constant.gravity, output will be 9.8. Yeah, we will do these programs later. Declaring and assigning value to a constant in Python. Value to a constant in Python. Declaring and assigning value to a constant in Python. Create constant.py as under a file. You create a file by name constant.py as under. Then keep this data in that. Pi is equal to 3.14. Gravity is equal to 9.8. Gravity is equal to 9.8. Yeah, that is the first step. We will come to a close at this point. Now create another file, say main07.py as under. Main07.py. Anyway, one main file. You can name it as whatever you want. I have named it as main07.py as under. Look. Then put the following code. Import constant. Import constant. Then print constant.py. Next line, print constant.gravity. Constant.py, the constant pi, then constant.gravity, the constant gravity. So you are, see, one thing you please observe. The file constant.py, look here. The file constant.py, see, this is the file constant.py, and the file main07.py. Both should be in the same directory. Both should be in the same directory. Constant.py, see, constant.py, as well as main, whatever I have given, main07.py, main07.py. Both should be in the same directory. It's a must. Otherwise, this visibility will be lost. So, obviously, keep both in the same directory and manage like this. Create another file. Say main07.py as under. Keep these lines. Import constant, then print in bracket constant.py, pi, again print constant.gravity. Now let us see. We can, yeah, it's already saved, auto saved. So now we will just go and run it. Just right click and run main07. Run main07. See, we are now getting 3.14 and 9.8. We have got the correct result. 3.14. Pi is actually, we had mentioned pi as 3.14. So we are getting 3.14 and 9.8 for gravity. So the result is 3.14 and 9.8. Okay, fine. It's so very simple a program. We will come to an end. Rules and naming conventions for variables and constants. Create a name that makes sense. For example, vowels make more sense than simply V. Look, simply a V. Vowels makes more sense than V. Use camel case notation to declare a variable. It starts with lowercase letters. For example, my name, look, M is a small letter, my name. Again, my age, again, M is a small letter. Again, my address, see, M is small letter. The next word, A address, it is A capital letter. Again, my age, next word, age, A capital letter. My name, next word, name, N capital letter. This is actually what is called a camel case. Use capital letters wherever possible to declare a constant. Examples follow. Pi, pi, gravity, mass, temp, etc. All are in capital letters. Never use special symbols like at the rate, comma, this hash, comma, dollar sign, comma, percent sign, etc. Don't start a name with a digit. Don't start a name with a digit. Constants are put into Python modules and meant not to be changed. Constant and variable names should have combinations of letters in lowercase small a to small z, comma, or uppercase capital A to capital Z, or digits from 0 to 9, or an underscore like this. Yeah, fine. Literals. Literal is a raw data given in a variable or constant. In Python, there are various types of literals as follows. Numeric literals, comma, string literals, comma, Boolean literals, etc. Numeric literals. Numeric literals are immutable, that is unchangeable. Numeric literals can belong to three different numeric types, namely integer, float, and complex. In the following program, we assigned integer literals into different variables. Here A is a binary literal, B is a decimal literal, C is an octal literal, and D is a hexadecimal literal. When we print the variables, all the literals are converted into decimal values. 10.5 and 1.5e2 are floating point literals. 1.5e2 is expressed in exponential form and is equivalent to 1.5 star 10 square, that is 10 into 10. 1.5 into 10 into 10. We assigned a complex literal, that is 3.14j in variable x. Then we use imaginary literal x dot image and real literal x dot real to create the imaginary and real part of the complex number. To create the imaginary and real part of the complex number. We are recording yet another program in Python. This is with regard to numeric literals. Yeah, look at the comment. See, I have put hash and then numeric literals are immutable. That means unchangeable. Numeric literals can belong to three different numeric types, namely integer, comma, float, and complex. Integer, float, and complex. Again, another comment is here. We use numeric literals in Python as under. We are giving some examples of using numeric literals in Python. Look, A is equal to 0B1010. It's a binary literal. It's a binary literal. B is to indicate that it is binary. Again, B is equal to 100, 100. It's a decimal literal. B is equal to 100, 100. It's a decimal literal. Then C is equal to 00310, octal literal. 00310, octal literal. Again, D is equal to 0x12C. 0x12C, hexadecimal literal. It's a hexadecimal literal. So, yeah, different literals: binary literal, decimal literal, octal literal, and hexadecimal literal. Now come to float literal. You have put a comment, float literal. Float 1 is equal to 10.5. Float 1 is equal to 10.5. Float 2 is equal to 1.5 E2. This is a different notation in floating point. This is called the exponential notation or scientific notation. The meaning of that I will explain now. Note that 1.5 E2 is expressed in exponential or scientific format, whose floating point equivalent will be just 1.5 into 10 into 10. E2 stands for 10 into 10. That is 1.5 into 100 is equal to 150.0. It's the floating, it's an exponential representation or scientific representation of floating point. Then comes complex literal. The complex literal. See, x is equal to 3.1 for j. X is equal to 3.1 for j. Again, x is equal to 7 plus for j. Yeah, 7 plus for j. Now comment this out and use the previous line, namely x is equal to 3.1 for j, and check the results also. Check the result also. You can use both these lines. You can check x is equal to 3.1 for j as well as x is equal to 7 plus 4j. I am now here using x is equal to 7 plus 4j. Okay, fine. Now look, you are going to print all these values. Print in bracket a comma b comma c comma d. Print a comma b comma c comma d. Next, print float 1 comma float 2. Next, print x comma x dot image comma x dot real. That is the complex number, then the imaginary part of the complex number, and the real part of the complex number. Yeah, fine. Now it's all very simple. Again, I am just telling you one more time. Note that 1.5 E2 is expressed in exponential or scientific format, whose floating point literal equivalent is just 1.5 into 10 into 10, that is equal to 1.5 into 100 is equal to 150.0. Okay, fine. Let us now see. We can just, let us run it. Just right click in the editor. Right click. Just to come and run PyCH07. Yeah, see, we have the result here. 10, the binary literals equivalent in decimal 10, then decimal literal 100, then this octal literal 200, and hexadecimal literal corresponding equivalent literal is 300. 10, 200, sorry, 10, 100, 200 and 300. Okay, fine. The different literals: binary, decimal, octal and hexadecimal. After that comes the float literal. Float 1, see, 10.5. As I told you, float 2, 1.5 E2 will be 150.0. 150.0. Now comes the complex literal. So the first one is complex literal. What is equal to x, the literal itself? That is 7 plus 4j. The next one is x dot image. That is the imaginary part of the complex literal. 7 plus 4j. In that, 4.0 is the imaginary part. That's it. That's why x dot imaginary part is 4.0. And the real part is 7.0. Real and imaginary. Real part is 7.0. That's it. It's a very simple program. It's an absolutely simple program on numeric literals. Numeric literals. We will come to an end.